Welcome my students. We have completed defined systems of units. Now we will form some derived units. We have to know the process of formation of derived units. So before going to derived units, we have to know which are derived quantities. The physical quantities which are formed by one or more fundamental quantities are called derived quantities. For example, speed is a derived quantity. Because speed is the rate of distance covered by a body with respect to time. So speed equal to distance by time. Similarly, density is another derived quantity. Density equal to mass per unit volume. Mass per unit volume of a substance is called density. So for getting the units of these quantities, speed, density, etc., speed, density, velocity, acceleration, momentum, force, work, power, energy, there are so many derived quantities. We have to know first the fundamental quantities, and with the help of fundamental quantities we will be able to form the derived units. So how can the derived units be formed? So speed, as speed is the rate of distance, the distance by time, so unit of speed will be distance by time. So we have to know the units of distance, that is length, and unit of time. Now derived units. Unit of speed in CGS system, unit of length centimeter, by time second, it is written as centimeter per second or centimeter second inverse. Or any one of the way, centimeter per second or centimeter second inverse can be written. In SI system, it will be meter per second or meter second inverse. Say density equal to mass by volume. So unit of density will be unit of mass by unit of volume. Unit of mass in CGS gram per volume centimeter cube. Volume means centimeter, volume means length into length into length, centimeter into centimeter into centimeter, gram per centimeter cube or gram centimeter to the power minus 3. And in SI, unit of density kg per meter cube or kg meter to the power minus 3. Similarly, we can form so many units. Now I am giving some examples. Velocity equal to displacement by time. Displacement by time. And displacement means length covered in a specific direction. So unit of displacement equal to unit of length. In CGS it will be centimeter by time second, centimeter per second, like speed, and meter per second. So units of speed and velocity are same. So speed is a scalar quantity, velocity is a vector quantity. So speed and velocity are one scalar and one vector having same dimensional formula. We will go through dimensional formula later on, and same units. Keep in your mind. Again I am saying velocity and speed are two quantities. The format is velocity is vector and speed is scalar, but both have same dimensional formula and same units. Keep in your mind. Now acceleration. acceleration is the rate of increment of velocity that with respect to time, that is velocity by time. You know, velocity is the rate of displacement, that is length by time, and by time. In place of velocity, L by T we can write, and divided by T, rate of velocity, so it is L by T square. Now the unit of length in CS centimeter by time square second square, or centimeter second to the power minus 2. In SI it will be meter per second square, or meter second to the power minus 2. This is acceleration. So what is acceleration? Acceleration is the rate of increment of velocity with respect to time, and deceleration is the rate of decrement of velocity with respect to time. In the next chapter, force and motion, we will go through this acceleration and retardation again. Retardation is also called negative acceleration. Now, momentum, another derived quantity. So its unit will be derived. Momentum is measured by the product of mass and velocity. Momentum actually is a kinetic property of a body possessed by virtue of its mass and velocity. It is measured by the product of mass and velocity. Momentum is not defined as the product of mass and velocity, it is the quantitative part, but qualitative part is that momentum is a kinetic property which is possessed by virtue of the mass of the body and velocity of the body. Now the unit will be unit of mass, that is gram, velocity centimeter per second, or gram centimeter second inverse. And in SI, kg meter per second, or kg meter second inverse. You can write in any way, gram centimeter per second or gram centimeter second inverse, because from the denominator, when it comes in the numerator, it will be minus power. Now to momentum to force, force equal to mass into acceleration, F equal to ma. Now mass into acceleration, that is unit of force. Unit of force in CGS, mass means gram and acceleration centimeter per second square. Gram centimeter per second square, it is also known as dyne. So behind dyne, the units which are hidden, that is gram centimeter per second square. And in SI, it will be kg meter per second square, that is also known as Newton. So 1 kg meter per second square equal to 1 Newton. See, I have written the name Newton starting with small letters. Why is the small letter used in this unit? Now we will go through the international rules of writing the units. Number 1, for writing units, small letter should initially be used. Any unit, if it is named after a person with proper noun, it will also be started with small letter, like Newton, like Joule, Kelvin, etc. All units should be started with small letter. Only degree Celsius or degree Fahrenheit, this will be with capital letter. but the abbreviated form of the ordinary units will be small letter, say meter small m, gram small g, second small s, kg small kg, etc. But the abbreviated form of the units which are named after a person will be in capital letters, say Newton N, Kelvin K, Joule J, etc. I am again saying the unit normally should be started with small letter, though it is named after a person. And the abbreviated form of the units in case of normal units will be in small letter. But the units named after a person, abbreviated form of those will be in capital letter. Number one, no full stop, comma, etc. should be used in the units. Not cm dot, but cm. Not m dot, but m. So no full stop, no comma, etc. should be used in the unit. No plural form, not ms, but 10 m, 10 meters, not 10 ms. Not 40 joules, but 40 joules, etc. So no plural form will be used in the units. This is the international rule of naming or writing units. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.